Right, so the first step for this problem is I'm going to multiply the conjugate. The conjugate is the reason we're doing this just so that we can cancel out the radical. That's the purpose, right? So when you do this, the method, the way that we're going to multiply, so this means this factor, we're going to multiply with this one. I'm going to make it the box. I can use the Punnett square. As some of you know what to do, you can use FOIL. That worked out as well. So x plus 6, negative 3. And then I'm using the other one, which is x plus 6, and then positive 3. What I do is that I'm going to multiply them in. Remember, when you multiply square root of x plus 6 and square root of x plus 6, it's going to cancel out the square root, so you have x plus 6. And then for this one, it's going to be negative square root of x plus 6. This one going to be positive x plus 6. And then this box right here, 3 times negative 3, give you negative 9. So when you do this, if you do it correctly, you see how this one is positive 3 and this one is negative 3? It's the same thing, but one positive, one negative, they're going to cancel out. So what you end up with is x plus 6 minus 9. So I see that you multiply, and you know what to do, but some of you, the problem was the notation. You didn't write it out correctly. So until you do substitution, until you plug in the values, you have to write out limit x approaching whatever the number that's given to you. So on the numerator, when I multiply these two, I end up with x plus 6 minus 9. So I copy these two up here. Okay, and on the denominator, I don't want to multiply them in. So this one, I would just leave it. The reason I want to leave it because I want to cancel out the denominator. Look at this one. If I plug in the 3, give me 0. I don't want that. So square root of x plus 6 plus 3. Question for me so far? Kind of sort of remember the steps, or like, I want you to put in the chat as we go through this. I want you to start to get me in the chat. Just tell me like, okay, I need to review this. This is a step that I got confused. So step number 1, multiply the conjugate. So I'm going to put down the steps. Step number 1. Step number 2 is that I'm actually multiply them out. Okay, let me know which step bother you, like which one that's give you problems. Because of the space, I need to erase the Punnett square. So I'm going to clear this one. Okay. All right. So now, if you notice, I look up here when x plus 6 minus 9, these two, we can combine like terms, which you should expect. When you do that, it's going to help you to cancel out the factor in the bottom. So that's going to be limit x approach 3. The numerator is going to be x minus 3 root x plus 6 plus 3. Okay, that's the whole purpose of us multiply the conjugate so that we can cancel out the factor in the bottom, and then we can get rid of that square root on the numerator. Okay. So anyone remember what should we do next? So this is step 3. What should I do next? Once I simplify the numerator, I can cross out the x minus 3, right? Because they are the same, so this cancel out. So that's the purpose of why we multiply the conjugate, because we want to cancel out some factor. So if you multiply them out correctly, you should be able to see one of the factors match, and then you should be able to cancel out the denominators. That's the purpose, right? I'm not going to spend the time to multiply and then not be able to do anything with that. So limit approach 3. Notice when I cancel out x minus 3, on the top it's turned into 1. On the denominator, x plus 6 plus 3. Now there's nothing else for me to simplify or cancel out. So now what I can do, so this, I can call this a step 4 after I simplify. Now I can do substitution. I can do direct substitution. I'm going to plug in the values. 3 plus 6 plus 3. Get me square root of 9 plus 3. 3 square root of 9 is 3 plus 3, so the answer is 1/6. So notice all the steps on the last line, I don't write limit x approach 3 anymore. As soon as I plug in the values, I don't have to write limit. I'm actually calculate the values. I don't have to write out the notation. So this is step 5. Plug it in and then simplify all the way to until you get the answer. Okay, so this is what you would do to solve this problem. Questions for me, right? Which steps? Why I have that number? So I have 5 steps total. Question on those steps. So what I normally do is I record the lessons. I'm recording myself talking right now. So the video that I'm sharing with you at the end of the day, most of the time is really long. But like I said, you don't have to watch every single thing. You can fast forward or only to the problem that you want to go back and review. So I'm going to ask you, take some time, go back and look at the example, look at the steps. That would help, right? So how do we feel about this? Is this something that was like, I'm okay, or another example? Or question of the steps, like another example, or move on? Another example, okay. Cool. All right, let's do another one. So for this one, if you see the square root, and for this one, I was asking you to do it by yourself, but we'll do this together, okay? So for this one, step number 1, what should I do? What is step 1 when you see this kind of problem, when you have that square root? Can someone tell me? Multiply the conjugate. So the conjugate is the one with the square root. So that's, thank you, Elena and Jessica. So multiply the conjugate is, I'm looking at the one with the square root, and you notice how this one is a minus. The conjugate will be the opposite operation. So it's going to be square root of x minus 1 plus 1, x minus 1 plus 1. So that's step number 1. So until I plug it in, the values, I have to write the limit notation. Okay. So what I would do now is that I'm going to so this is step 1. Step 2, I'm going to multiply them together. The denominator, I will not multiply because I want to cancel that one out. So I'll leave it x minus 1 plus 1. Okay, so I'm going to multiply the numerator. So make the box x minus 1 square root negative 1, x minus 1 positive 1. So I'm going to multiply them in. The square root going to cancel out, so I have x minus 1, negative 1, square root of x minus 1, positive 1, x minus 1. The bottom, the last box, going to be negative 1. So if you do this correctly, you notice that these two will cancel out because one positive, one negative. So I ended up with x minus 1 and minus 1. So these are the two that I would use. So that's step 2. Question for me. Are we okay so far? What are the first two steps? For the one we'll ask for another example, is this better? We don't, so one of the question is a really good question. Do we have to make the conjugate positive? No, it's dependent on what's given to you. So let's see, if you look over here, the one given to you, whoops. The one that given to you is in negative, so you make it into positive. If they gave to you the operation is positive, then you will turn into negative. So you always do the opposite of what's given to you. So over here, it's based on the operation that given, the one that I highlight over here. If it's minus, I'll turn into positive. If it's plus, I'll turn into negative. All right, so I'm going to clear the Punnett square. So over here, I'm going to do the next steps. Limit. Whoops. I need to erase this. Okay. So this one is equal to limit x approach 2. Up here, I can see -1 and -1. That will turn into x minus 2. You kind of guess. Some of you is like, I saw the pattern is when I see it, because it's always probably most likely will match with the factor that I want to cancel out. It should be. So x minus 2 square root of x minus 1 plus 1. Okay, what do I do next? Once I simplify my numerator. Now what do I do next? What should I do for step 3? I'm going to cross out the common factor, right? That is good. So now what I have is limit x approach to 1 over square root of x minus 1 plus 1. Right, so I simplify. Now I have nothing else to simplify further. So I'm just going to do direct substitution, which is going to be 1 over square root of 2 minus 1 plus 1. So square root of 1 minus 1, that's 1, sorry, plus 1. So that's 1 plus 1, this gives you 1 over 2. This looks like a 3. Okay. And this is the answer. So step 3, step 4, and then step 5 is the one where you plug it in. So there are 5 steps total. Step number 1, multiply the conjugate. Step number 2, simplify. Step 3, cross out the common factor. Step 4, simplify, and then step 5 is just plug in the values, direct substitution, and then do the rest to get the final answer. So for this problem is probably the hardest problem that you will deal with this topic to find a limit. So we're definitely going to spend more time on this one. We're definitely going to go back and review. So if you're still not sure what to do, make sure that you join me for office hours. I'll go back and look at the notes. Let me know. You have to communicate that with me. If you don't say anything, I assume we're okay, and I'll move forward. Okay. All right, so that is multiply the conjugate, and the new one that we want to work on today is the piecewise function. Piecewise function, so this is the last type of problem that we can look at to find limit, okay? Piecewise function is when you have more than one equation given to you. But when you graph, the graph is not going to be like one function. It's like 2 functions put together, 2, 3, or even 4. But we're just going to focus on 2 functions put together, and then we see what is the limit at that point. Okay, so piecewise function is this type when you have more than one function. for that problem. So remember the limit, when we find the limit, if I have this graph, so if I have a graph and I want to find the limit of that graph at a given point, Joseph, there's a link for you to join Paradox if you can join. So what you do is that if I have this, if I have the graph and then I have a function look like this, if I want to find the limit at this, what I do is I'm looking at the y value and see what value this approaches to, right? So that's a limit with the graph. Same idea. So we look on the left side, we look on the right side to see what happens. Do they come to the same point? If they do, there's a limit. If they don't come to the same point, for example, if I have another graph, it's come here, and then this P is over here, right? So there's no limit at 0. Right? So that is how we know if there is a limit or we don't have a limit, by looking the left side and the right side. If they are equal, that means they come to the same point, there's a limit. If they don't come to the same point, there's no limit. That is the piecewise function that we looked at. So you can think of this, if I'm drawing this number line, I have 2, right? The first one say x is greater than 2. So this is the right, anything greater than 2 is on the right side. This one is say anything, the graph is from anything less than 2, which is the left side. If you think of a number line. So we have the left and the right. This by far, I think I like this one the most, is we just compare the values. So here's what we're going to do. We're going to find the right limit. To find the right limit is really simple. I'm using this function and plug in the values that are given to me, which is 2. So 3, 2 square minus 1, 3 times 4 minus 1, 12 minus 1, so this gives me 11. So this is the right limit. I'm doing the same thing to find the left limit. What do you think I should do to find the left limit? Can you guess what I would do next? Anyone? I will plug it in, but which function should I plug it in? The next one, right? The one on the bottom? Yes, the second function. So I will have 5 times 2 plus 2, 10 plus 2. This gives me 12. So I have the right limit is 11. The left limit is 12. Is there a limit at 2? If I'm comparing these two values. They don't have the same value. So is there a limit at 2? No. That is correct because the limit, they don't match. So the limit will be D and E. So this is your final statement. That's how you will show your answer. Like the limit x approach 2 f of x is D and E. Why? You don't have to tell me why because you already show your work from the right limit to find the left limit. They don't match. There is no limit. Yes. So piecewise function, what you need to do is plug it in. You're going to tell me which one is the right limit, which one is the left limit. Plug them in. Compare the values. If they have the same thing, then that is a limit. That value is a limit. If they don't have the same values, then it's D and E. Okay. How do we feel about this one? Is this better? I think this should be a better problem than the other one. Okay, let's do another one. So this one, the only thing you have to tell me which one is the left limit and which one is the right limit. That the one thing is may give you trouble. Okay, so if I look over here, I'm going to draw my numbered line, 2, right? So this one is less than 2, so be very careful. This one is less than, so this should be, this is less than 2, so this is the left limit. Okay, so this is the left. And the second equation is like greater than 2, so it's up here, so this is the right limit. This one, I'm going to do this one more with as an example, and then the next one I'm going to ask you to do on PADEC just to check in. So for this one, just follow what I do first. I'm not asking you to do this one yet, okay? All right, so the one thing that I will pay attention to is, can you identify the left and the right limit? That's all, right? Over here, make sure you look at the inequality. So the left limit, you can say left limit, 2x. So when I cut this problem, that should be the notation right here, but it's just disappears, should be limit x approach 2. Okay, so 2 times 2, my pen is not working. Okay, 2 times 2 plus 5, 4 plus 5, which is 9. Then I'm going to do the right limit. Same thing, 4 times 2 plus 1, 8 plus 1, which is 9. So what is the limit of this problem then? It's not D and E, for those who tell me D and E. It's not D and E. Because look at the values for the left limit and the right limit. They are the same. So the limit is 9 because the left limit is 9 and the right limit is 9. They match. So they have the same values. That is the limit. So the notation is really important. So I'm going to look at, can you tell me which one is the right limit, which one is the left limit? And then the final answer, you write the function correctly. So you notice limit x approach to f of x. I don't have to copy down the entire function again. If I say f of x, I mean this is the function. It's right there. That's the only thing I looked at. It's 9. Okay. Questions on this type of problem, piecewise functions? Okay. All right, let's check in. This is a piecewise function. I'm going to ask you to try this one. Okay. We're going to do this one. Find a limit x approach 3. So go ahead and do this on PADEC. If you do in a piece of paper, I'm going to ask you to email that to me later. So this is a check-in point. So you should see a grade for this one in Power School. So this is going to be March 3rd, check-in. Okay, so go ahead and do this in PADEC.